In architectural classification scheme, we have discussed the Flynn's classification, that is SISD, SIMD, MISD, MIMD in the last class. So the next one is the Feng scheme. So the Flynn's classification is mainly based on the degree of parallelism to classify parallel computer architecture. So the main parameter used for in Flynn's classification is the degree of parallelism. Okay, the maximum number of binary digits that can be processed per unit time is known as the maximum parallelism degree. It is denoted by P. So what is the maximum parallelism degree? The maximum number of binary digits or bits that can be processed per unit time. So the average degree of average parallelism degree can be calculated as, it is denoted by PA. PA is equal to summation of I is equal to 1 to T Pi divided by T, where T is the total processor cycle. Okay. So the utilization of a computer system within T cycle is given by mu, is denoted by mu. Mu is equal to PA by P. What is PA? PA is equal to summation I is equal to 1 to T Pi divided by T. So PA by P means summation I is equal to 1 to T Pi divided by T into P. When the Pi is equal to P, that is the at each ith level, if we have the maximum degree of parallelism, then it means that the utilization is 100%. The utilization rate depends on the application program being executed. So the utilization rate is it depends on what type of program, what type of application program is being executed. So I repeat, the Flynn's classification is based on the degree of parallelism. So the maximum degree of parallelism is the number of bits that can be processed per unit time, from which we can calculate the average degree of parallelism. It is denoted by PA, which is equal to summation I is equal to 1 to T Pi by T, where T is the total processor cycle. Then the utilization of a computer system within T cycle is given by mu is equal to PA by P, that is PA is equal to summation I is equal to 1 to T Pi divided by T into, then mu PA, that is equal to PA. So PA by P is equal to summation I is equal to 1 to T Pi divided by T into P. When the Pi is equal to P, we can achieve that the utilization, we can achieve the 100% utilization of the computer system. The utilization rate depends on the application program that being executed. Okay, a bit slice is a string of bits, one from each of words at the same vertical position. So bit slice means it is a string of bits, one from each of the words at same vertical position. That is, if we are arranging different words. Okay, for example, RAM is a word, ROM is a word, COM is a word. Okay, so these are words of 3 bits length, isn't it? Okay. So a bit slice is the string of bits, one from each of the words at the same vertical position. So if you are taking the one as the vertical position, then we can take the bit slices RRC, RAM, ROM, COM. Okay, if we are taking the second bit level, then it is AOO. At the third bit position, the bit slice is MMM, isn't it? So a bit slice is a string of bits, one from each of the word. One bit is taken from each of the words at the same vertical position. So the maximum parallelism degree PAC of a given computer system C is represented by the product of word length N and the bit slice length M. that is word length is denoted by n and the bit slice length is denoted by m. So the pair nm corresponds to a point in the computer space. So here, according to Feng's classification, here we have four types of processing method. The first one is word serial, bit serial, WSBS, word serial, bit serial. Next one is word parallel, bit serial, word serial, bit parallel, word parallel and bit parallel. Okay, so in word serial and bit serial has been called bit serial. In the PDF it is given it as bit parallel, so we should correct it as bit serial processing, because here one bit is processed at a time. So here we have several words. Okay, several words of n bits or m bits, whatever it is, several words of several bits. So among which from each word one bit is processed at a time. Okay, that is word serial and bit serial. Word serial, bit serial is called bit serial processing because one bit is processed at a time. And the next one is word parallel and bit serial. It been called bit slice processing because m bit slice is processed at a time. So here the bit slice is processed, that is word is parallel and bit serial. Okay, so it is called bit slice processing. I have explained you what is a bit slice. Bit slice is the bits taken one bit from each word at the same vertical position. Okay, so if you are arranging the words in a matrix form, the bit positions at a particular vertical position from each bit from each word is processed here. Okay, so here it is word parallel and bit serial. Then word serial and bit parallel is found in most of the existing computers and has been called word slice processing because here one word of n bit processed at a time. Here one word is processed at a time. In WSBP, here a single word is not processed, then one bit from each word. Likewise, number of bits from several words are at same vertical position is processed. And word parallel and bit parallel is known as fully parallel processing, in which an array of n by m bits is processed at one time. So word parallel, bit serial, it is called bit serial because only one bit is processed at a time. Word parallel and bit serial has been called bit slice processing. Here m bit slice is processed at a time. Word serial and bit parallel is found in most of the computers. It is called word slice processing. Here one word of n bits is processed at a time. Word parallel and bit parallel is known as fully parallel processing, in which an array of n by m bits is processed one time. So here we have the Feng computer classification. So here it is WSBS, word serial, bit serial. Okay, WSBS, word serial, bit serial. Here n is equal to 1, m is equal to 1. So degree of parallelism is 1, 1. And WSPBS, it is n is equal to 1 and m greater than 1. Okay, that is computer models are star and MPP, DAP, and WSBS computer model is minima. And here it is the degree of parallelism is 1, 256. Okay, in MPP it is 1, 16, 384. And in DAP it is 1, 40906. WSBP it is n greater than 1 and m equal to 1. It is word slice processing. Okay, so it is IBM 370/1, 168 UP 64 1, CDC 6600 it is 60, 1, Burrow 7700 it is 48, 1, VAX 11 bar 780 it is 16 or 32 comma 1. WBP n greater than 1, m greater than 1. iliac 4 is an example 64, 64. So here it is n and m. What is n? As I told you, n is the word length, okay, and the bit slice is denoted by m. Word length, so n, one bit at a time is processed, that is 1 comma 1. There is no parallelism. N equal to 1 and m greater than 1. More than one bit slice is processed. One word, then among which different bits are processed. Then in WSBP, one word at a time is processed. That is why a word of 64 bits is processed, n greater than 1. Then in WPBP it is n greater than 1, m greater than 1, 64 words with 64 bit each is processed. Okay. Then the third one is Handler's classification. Handler's proposed an elaborate notation for expressing the pipelining and parallelism of computers. He divided the computer at 3 levels. That is the processor control unit PCU, arithmetic and logic unit ALU, and bit level circuit BLC. PCU is nothing but our CPU. Okay, ALU correspond to a functional unit or processing element in an array processor. BLC is correspond to the logic needed for performing the operation in an ALU. So he uses 3 pairs of integers to describe the computer. That is, the computer can be described 6 different entities, integer entities. Okay, that is k, k dash, d, d dash, dash indada that adu vittu edana, w, w dash. These are the 6 entities. K denotes the number of PCUs, the processing control units. K dash is among the number of PCUs, how many can be pipelined. Okay, the number of PCUs which are pipelined. D denotes the number of ALU controlled by each PCU, and D dash denotes the number of ALUs that can be pipelined. W is the number of bits or processing elements in ALU. W dash denote the number of pipeline segments. So these are the 6 entities Handler designed for describing a computer. And some star is the operation that is used to show that the units are pipelined. Plus is the operator used to show that the units are not pipelined. V is the operator used to show that the computer hardware can work in one of the several modes. That is, several modes are there and the computer can work in one of the several modes. And the tilde sign, okay, tilde operator is used to show that the range of any parameter. We will discuss this with an example. Okay, so here we have described the degree of parallelism and pipelining in the 3 different computers, that is CDC 6600, Cray 1 and iliac 4. The CDC 6600 is given by, this model consists a single processor which is supported by 10 IO processor. One control unit control one ALU with 60-bit word length. Okay, the ALU has 10 functional units which are pipelined manner. 10 IO processor work parallel with each other and with CPU. Each IO processor contains 12-bit ALU. So the description of the 10 IO processor is 10 IO processor, that is the number of processors. Okay, so that 10 IO processor work parallel with each other and with CPU. Then each IO processor contains 12-bit ALU. So what is? These are the number of ALUs controlled by the number of PCU, number of ALU, the number of bits processing in that ALU. Okay, so it can be described as 10 IO processors are there. Each IO processor is controlled one ALU and there exists 12-bit ALU. Each IO processor contains 12-bit ALU. Then the CDC 6600 main, that is the main processor is one processor, 1 into 10 ALU, then each of which is 60 bit word length. Okay, one control unit control 1 ALU. Okay, so there is one processor and one control unit control 1 ALU and each ALU with 60 bit word processor. So 1 ALU, then one control unit, then that one ALU that can be controlled by 10 IO processors and 60 bit word length. So in this model, the main IO processors are main and IO processors are pipelined. So we can use this star operator, IO processor star main processor. So this IO processor endana 10, 1, 12, CDC main 1 into 10, that can be taken as 10 also, 60. Okay, then Cray 1, this model having 64-bit single processor computer. ALU has 12 functional unit and 8 of which are pipeline. The range of functional units are 1 to 14. So having 64-bit single processor. So the number of processors is 1. How many of them can be pipeline? That is not mentioned. So it is 1. Then the ALU has 12 functional unit and 8 of which are pipeline. So it can be described as 12 into 8. Then the range of functional units are 1 to 14. So 1 till 14. Okay, so this is the description for Cray 1 according to Handler's classification. Then the next we have Iliac 4. Iliac 4, it is made up from arrays which are connected in a mesh. The total 64 arrays have 64-bit ALU. It has 2 DEC PDP 10 as the front end, whereas Iliac 4 accepts data from 1 PDP 10 at a time. So 2 processors are there. It is connected to 1 ALU and it is then this also 64 to 64 bits, 64 it is made up from arrays which are connected in a mesh. The total 64 arrays have 64-bit ALU. It has 2 DEC PDP 10 as a front end. Iliac 4 accepts data from 1 PDP 10 at a time. Then this model will also work in half word mode. At that time it has 128 processor of 32-bit each instead of normal 64-bit processor. Okay, so it is 36 functional units, that is not mentioned here. So it has 2 processors, 1 ALU, and that ALU has 36 functional units that can be worked in the IO processors. The description is one processor can be worked as a 64 arrays having 64-bit ALU. Okay, so here it is also 1, 128, 32. So it can be worked as 2136 is common, that is the processor description. Can be worked in either of these 2 mode, half word mode or full word mode. 164 versus 128, 32. Okay, so this all about the architectural classification scheme in the parallel processing. So we have discussed the Flynn's classification and Feng's classification and Handler's classification. Okay.